Hey guys, we're going to continue using inverse trigonometric functions. In a calculator, I want to type in sine 30 and that gives me 0.5 or 1/2. But notice if I type in sine of 150, that also gives me 1/2. So more than one angle measure can give the same ratio, and that works for sine, cosine, and tangent. All coterminal angles will have the same ratio, but more than one angle that is between 0 and 360 will also have the same sine, cosine, or tangent ratio. Okay, so for sine, it was 30 and 150. And those look like that. And they both have the same reference angle measure of 30 degrees. For cosine, 30 degrees, you can also get the same ratio out of cosine 330 degrees, which happens to have a reference angle of 30 degrees also. For tangent, 30 degrees and 210 degrees, which also has a 30-degree reference angle. Those two would give you the same trigonometric or the same tangent ratio. For sine, it's across the y-axis. Cosine, same across the x-axis. And tangent, same across the origin. It's where you can find the same ratios. So when you're looking for a first angle, say instead of sine 30 equals blank, say you had sine theta equals 1/2. To get that first angle, you would use inverse trig functions. So there's a way to find the second angle, and it's different for sine, cosine, and tangent. For sine, once you've found that first angle, 180 degrees minus that first angle will give you the second angle. For cosine, the opposite of the first angle will give you the second angle. And for tangent, 180 plus the first angle will give you the second angle. So for sine, cosine, and tangent, we need to remember subtract, opposite, and add. And here's how I remember. For sine, it starts with an S. S is also for subtract. Cosine, it doesn't start with O, but it's got an O in it. O is for opposite. Tangent doesn't start with A, but it has an A in it. A is for add. So for 6 through 9 here, I want to solve for theta. And theta has to end up being between 0 and 360. And we're going to be able to get two solutions. So to get the first solution for theta, theta equals the inverse, or arc sine, root 2 over 2. So second sine square root of 2 over 2. And that's 45. So the first angle is 45 degrees. So sine has an S for subtract. 180 minus 45 is 135. That's my second angle. Here's how I can check that. First of all, I need to see what decimal I'm looking for, and I do that by square root of 2 divided by 2. Okay, so that comes from right here. Equals 0.7071. Now, sine of my first angle, 45, same decimal. Sine of my second angle, 135, also the same decimal. That tells me that my answers are correct. Okay, number 7, theta is arctangent, opposite of the square root of 3. Second tangent, negative square root of 3. Negative 60 degrees. Okay, the problem is my two answers are supposed to be between 0 and 360. So I need a coterminal angle between 0 and 360. So plus 360 is 300 degrees. Tan has an A for add. 180 plus 300 would probably actually be easier, since 300 is going to give me something above 360 and I'll have to find a coterminal. I'm actually just going to use that original negative 60. 180 plus negative 60 is 120 degrees. That's my second angle. So the opposite of the square root of 3 is that decimal, negative 1.732. Tangent 300, same decimal. Tangent 120, same decimal. That means my answers are correct. Number 8, theta equals arc cosine 1/2. Second cosine 1/2, or 0.5 will do. 60 degrees. Cosine has an O for opposite. So the opposite of theta is negative 60 degrees. And that is not between 0 and 360, so I need to add 360. And I get 300 degrees. So to check that, 1/2 is 0.5. I really don't need to put that in. Cosine 60 and cosine 300 both equal 1/2, or 0.5. And then number 9, theta equals arctangent negative 1. So inverse tangent of negative 1 is negative 45. That is not between 0 and 360, so I have to add 360. And that's going to give me 315 degrees. Tan has an A for add, so 180 plus, and if I do the 315, it's going to be too big, so I'm going to have to subtract 360 to get a coterminal between 0 and 360. So instead, I'm just going to do plus negative 45. 180 plus negative 45 is 135 degrees. I don't have to put negative 1 in the calculator. I just know that's going to be negative 1. So then tangent 315 is negative 1, and tangent 135 is also negative 1. That tells me we did these correctly. Evaluate each expression, assuming all angles to be in quadrant 1. So here's what this looks like. This arc cosine, 3/5. That, as an arc function, that means this is an inverse. So this right here, what it's going to give me is the input. Since it's an inverse, it's going to give me theta. What that really tells me is that these numbers are adjacent and hypotenuse because it's arc cosine. By Pythagorean theorem, a common Pythagorean triple is 3, 4, 5. So that one right there is going to be 4. Tangent is opposite over adjacent. 4/3. So this right here represents my theta. What that tells me is opposite is root 45. Hypotenuse is 7. I want cosine, so I'm going to have to use the Pythagorean theorem. So that's root 45 squared plus b squared equals 7 squared. We're going to move this over here. 7 squared minus root 45 squared is 49 minus 45. So b squared, 49 minus 45 is 4. Square root of 4 is 2. Cosine is adjacent over hypotenuse. That will be 2 over 7. Okay, the next one. Theta is represented by arc sine, which means opposite over hypotenuse, 3 over 7. I need tangent, that's opposite over adjacent, so I'm going to have to do 3 squared plus b squared equals 7 squared. 49 minus 9 is 40, so b squared is 40. So this is the square root of 40, and we'll simplify that as we get to the end of this one here. So tangent is 3 over the square root of 40. 40 is 4 times 10, so that's the square root of 4 times 10. And that means 2 times the square root of 10, so it's 3 over 2 root 10. Now I need to multiply the numerator and denominator by the square root of 10, so that's 3 root 10 over, and 2 times the square root of 10 times the square root of 10 is 2 times 10, which is 20. And then theta here is represented by arctangent, root 35 over 1. I need sine, so there's my opposite over adjacent. I need sine, which is opposite over hypotenuse. Square root of 35 squared plus 1 squared equals c squared. That's 35 plus 1, or 36. Square root of 36 is 6. Sine is opposite over hypotenuse, so that will be the square root of 35 over 6. Square root of 35. 35 is 7 times 5. I cannot simplify that, so that is going to be my final answer.
And now we'll finish this lesson with some review. If a plane flying north has a destination that is 63 miles north and 11 miles west of its present location, okay, so here's the plane right here, and its destination is right here, 63 miles north and 11 miles west, at what angle should the plane turn to head directly there? So instead of flying 63 miles north and 11 miles west, what angle should it turn in order to head directly toward its destination? Okay, so we have an angle here, and we have the opposite leg and the adjacent leg, and that's tangent. So tangent theta equals the opposite over the adjacent. When the angle is the variable, that is a time that we want to use an inverse. So theta is arctangent 11 over 63. Okay, so we'll pull in our calculator here. We'll check the mode, and we are in degree mode, so that's good. Okay, so second tangent, 11 over 63, and that is about 9.9 degrees. So theta is 9.9 degrees. Find the exact value of secant, negative 240 degrees. Negative means clockwise, so we've got 90, 180, and then if we go all the way here, that's 270, so we'll stop a little short right about there. Is our 240 degree, or our negative 240 degree angle. Okay, so we need the reference angle, so we're going to make a right triangle here, and we need this reference angle measure. Okay, so to get that reference angle measure, we'll do 240 minus 180, and that is 60. So we have a 60 degree reference angle here. So on a 30, 60, 90 triangle, we have 1 for the shortest leg, 2 is the hypotenuse, and the longer leg is the square root of 3. Remember that this hypotenuse, or the radius, will always be a positive number. but opposite and adjacent, which are y and x, can be negative. Left is negative, up is positive. Okay, so now we want secant, and secant is reciprocal of cosine, which is hypotenuse over adjacent. The hypotenuse is the radius. The adjacent right here is the x value. So it's r over x, which is 2 over negative 1. So our value for secant negative 240 is negative 2. And last, if cosine theta is square root of 56 over 9, find tangent theta. Okay, so we'll draw a picture. There's theta. And cosine is adjacent over hypotenuse. So that square root of 56 is adjacent, 9 is hypotenuse. Find tangent, which is opposite over adjacent. Okay, so to do that, we need to know opposite. So we have square root of 56 squared plus b squared equals 9 squared. So that's 81 minus 56, and that is 25. And the square root of 25 is 5. So tangent theta is 5 over the square root of 56. Okay, now we can't leave this radical in the denominator, so we'll multiply top and bottom by the square root of 56. So we get 5 root 56 over 56. Okay, now the square root of 56 can be simplified. 56 is 7 times 8. So it's 7 times, and then 8 is 4 times 2. And I've got a square number right there. So the square root of 4 is 2, so I'm going to bring a 2 out here and multiply it by this 5, so that gives me 10. And that leaves me a 7 and 2 left over inside, so it's the square root of 14. And that's all over 56. And 10 over 56 does simplify. 2 goes into 10 5 times. And 2 goes into 56 28 times. And 5 over 28 does not simplify, so my final answer is 5 root 14 over 28.